Good morning. My name's Dave Roberts, and I'm extremely pleased to be here today. I work for OSIsoft. I've worked with the company now for 10 years, and in my role as a fellow with OSIsoft, I'm responsible on a global basis for our smart cities initiatives. And what I'd like to talk about today is a little bit about OSIsoft, just to introduce you to who we are and what we do, if you don't know that. And then talk a little more specifically about what we're doing here in San Leandro and some of the prototyping and new product innovation we're doing right here at home. So many of you may know us, building over on Davis Street. We're over 1,000 employees now. When I joined the company, I think I was number 185 or something like that. And we invest somewhere between 30 and 40% of our revenue back into R&D. Most of that R&D and development is done here in San Leandro. We do have development offices in other locations, but the core of our product development is done right here in San Leandro. And we do business in 110 different countries around the world. We have 26 offices in 16 countries. We have installed our software over 14,000 times for our customers, going back to 1982. Our first customer was a Hawaii refining company in Honolulu, Hawaii, back in 1982, when Dr. Pat Kennedy went out there and had the job of trying to pull all the data together across a refinery. They are still a customer today. The technology has evolved a lot since computing in 1982, but they have a continuous data set on how that refinery has operated for the last 30 plus years, and can go back and trend and do analytics on how that refinery has performed. The two previous speakers touched base on the Internet of Things and machine data and cyber autonomous or cyber physical assets that are out there. And we see the same thing. We see these assets that are out there becoming much smarter, connected, and having edge compute capabilities. So the software that we used to run and do and the analytics we used to run in a centralized way are now starting to drift into these hybrid scenarios where you have edge and cloud and something new in between called fog computing. Anybody heard of fog computing? It's a new one to me, but it's essentially the idea that you have a hybrid scenario of on-premise and cloud, and you're going to do some of your analytics and connectivity. The key point is that we see millions of sensors, we see hundreds of thousands of these cyber autonomous assets in any given city, and getting the data from all of those together into a common data platform is a big job. So that explosion of data really hasn't changed what people are trying to do with the data, though. At the end of the day, people are trying to run a business as a sustainable enterprise. Sustainability in terms of energy use, water use, and carbon, but also economically sustainable. You want to create a business and you want that business to be sustainable so that your employees can raise their families and have jobs and income, and all of those things drive the sustainability of a business, and that's really at the core of this. Out of that, William touched on the idea of increasing asset availability, reliability, production, improving the accessibility to information. How do people get information out of those assets? Reducing capital costs and minimizing maintenance costs. Those drivers are still the same. What's changing is the data infrastructure underneath is getting much more robust. So your ability to connect to individual assets like a building or a car, or to a sensor like a thermostat or a pressure sensor, are getting much more robust and much faster, so you can drive these kinds of use cases with a whole different level of infrastructure. That's what we do as OSIsoft. We provide the data infrastructure that allows all this data to flow from sensors, from assets, and from systems like building management systems that might be running this building, and bring them all together into a common data platform. And we can do that at a single location, or we can do that across a factory, or we can even do that across a city. And that's what we're doing here in San Leandro, is prototyping how you can bring a whole city's data infrastructure together into a common platform and be able to present it for these use cases and drive high-value analytics and outcomes that ultimately lead to the sustainability and the economic sustainability of the businesses and the stakeholders that participate in that city. We're not doing that by ourselves. We are a 1,000-person employee, and we have some very large big brothers. We work with Microsoft very extensively. One of the innovations that Pat brought back in 1992, he brought the first Windows system into an industrial, Windows server into an industrial environment. Everything else was Unix-based and mainframe-based systems. And we started working with Microsoft back in 1992, 22 some odd years ago, to bring Windows into the industrial space. And we've been on that wave with them. We have a very, very deep technical relationship. And this picture really represents what I'm talking about in terms of getting at sensor data, system data, asset data, how you store stuff locally for local users, how you leverage the cloud, and all of that built on a highly secure, highly scalable infrastructure to make that happen. The Pi component of that is really broken into three parts. The data streams, you can think of a sensor, a temperature sensor. It's going to push out data, and it might push out that temperature value once a second, once a minute, once an hour. Some sensors produce data 120 times a second. We do something called a phasor measurement unit to look at the health of the electricity grid. That produces data 60 times a second. It's sending out a data stream and a value. So when we start to think about ingesting all that data, those data systems get to be things like 1 million events per second into the database. So that's a huge volume of data that's streaming into this environment. Now, of course, having all this data is great, but to make sense of it is also a big challenge. A lot of people talk about this idea of drowning in a sea of data while being thirsty for knowledge. I hear this quote over and over again. Part of what we do is we put context around that data to make it consumable by people. That context can be a description of what the asset is. I'm a boiler, I'm a pump. It can be a description of where that asset is located. My GPS coordinates are, I am connected to, my serial number is, I was installed on, my last service date was. All of those are contextual data that wrap around this high volume sensor and time series data to help users make sense of this. And then from all of that, we drive high-value analytics, some use cases, how you look at downtime and shutdowns of assets and asset management and process improvements and things like that. This is at the core of what OSIsoft does, and this is a product we make. We make one thing called Pi. It's made right here in San Leandro. We've been doing that for over 30 years. We are the leader in many core heavy industries. If you look in power and utilities, something like 70% of the power generated in the North American market goes through a Pi system. Here in California, the California ISO that runs our electricity grid uses the Pi system. They have a several million data stream environment where they go out every 4 seconds and they're pulling data across the entire California grid back into their environment. In oil and gas, we're in something like 55% of the refineries worldwide. All of the majors use our technology for their upstream, midstream, and downstream applications inside the petrochemical business. Chemicals, petrochem, pharmaceuticals, life sciences, metals and mining, pulp and paper, all big, heavy process industries. And then increasingly lately, you'll see Pi systems starting to be deployed in critical facilities, communications, things like data centers and airports and sports facilities and telecommunications and other types of environments where this data infrastructure is monitoring the health and performance of those critical facilities. Okay, so let's bring that back to San Leandro a little bit and put it in the smart city context. So here's the core of our vision, right? Is that to deliver a smart city, you need a common data infrastructure that connects all the previous islands of data in that city context, so that as an individual user, you can optimize your facility, your asset, your plant, your manufacturing facility, your vehicle, your building, and use that data for your own benefit, but then also have an environment where you can publish your data in a secure way for greater good and greater outcomes, right? So the barrier to entry there, though, we call it the Snowden effect, is getting people comfortable with the idea that publishing thermostat data out of their building is not a big deal, right? How do you get people comfortable with the idea that there's a greater good, right? When we start to drive for sustainability outcomes, energy efficiency outcomes, we need to be able to pull that data together. How do you do that in a way that manages security, privacy, Snowden concerns, all these kinds of things? This is what we're working on right here. This is another way to look at that. We define Pi as a common data infrastructure that connects all those physical infrastructures. So what we're doing in these smart cities is we're going out to the individual physical infrastructures and deploying Pi systems. PG&E has a Pi system. They connect, we have a Pi relationship there. The water system, waste management, critical facilities, buildings. Right here in San Leandro lately, with Deb's help, we've been doing a lot of work in the building space, right, for schools and firehouses and public buildings, and bringing that data together. We've been doing those same connections for 30 years inside the fence. This is inside the fence of a plant, connecting to the water system in a plant, connecting to the electrical system in a plant, connecting to the telecoms in a plant. This is nothing new for us from a technology perspective. What's new is the applicability and doing it at scale in a cityscape. The other concept I want to touch on here is, I think our first speaker this morning touched on it, and it's not my term, but I like it, the triple helix effect. And I think this is also a critical component to driving the economic sustainability. And the triple helix was actually defined out of Stanford and why Silicon Valley became Silicon Valley in the War Department years around World War II. And it's roughly defined as this idea of how does academia, industry, and government collaborate to drive economic development. So the role of academia really is funded, directed research, and that funding may come from NSF or federal sources or state level sources like the California Energy Commission or the PUC or the NSF or the DOD. And that's typically done through directed research projects where you have postdocs, PhDs working on funded research. Same time, the role of academia is curricula development around that research, so the students are actually involved in some of these directed research projects. It creates workforce, kids coming out of school that want jobs, but it also creates entrepreneurs that create intellectual property while they're working on this directed research, and they may be able to license that back from the university or have some other commercialization path. And then academia really plays a strong role in forging partnerships because they build coalitions between public sector and private sector by the nature of how they're funded. The role of industry, OSIsoft included, we have the ability to monetize that intellectual property. That's our job out there, is to take this stuff, turn it into a product, put licensing around it, put structure around it so that we can deliver it to customers, service customers, and make customers happy with it so they'll pay us for it, right? So our job is really that economic engine because we can monetize this intellectual property. And we tend to think of ourselves as market experts. And the role of government, William in the back row, thank you. You're really a policy neighbor. And Mayor Cassidy, are you still here? In terms of an example of San Leandro is a policy enabler to work together on this conduit project to bring lit San Leandro. The city council and the mayor had to work together with private industry, Pat Kennedy, to come up with a policy that would enable this. And so you can see this pulling together this idea of triple helix. And we've seen where there are cluster effects happening around the world where when we see this level of collaboration, the economic development follows. Everybody talks about, why Palo Alto is Palo Alto, but there are others. Raleigh, Durham, right? Charlotte, Chicago, San Diego. There are these clusters that are emerging. San Leandro is a prime example of this. So we put those together. If you put this idea of a very rich data infrastructure here in San Leandro that's connected to all the physical infrastructures, and then you create connectivity to academia that can drive intellectual property, new product development, those kinds of things, you start to create a very interesting economic development path coming together. So lastly, because I'm coming up out of time, I want to talk a little bit about what we're doing here from an OSIsoft product perspective and some innovation. San Leandro is also a test bed for us for some of the new product we're developing. We have a partnership with a company called Esri. Have anybody heard of Esri? Anybody use a map to get here today? So Esri provides the GIS database and software that drives almost every map on the internet. And we've created a partnership with them to bring together what we do, which is this very rich time series data, with what they do, which is a geospatial mapping and context. So now you can look at this rich data in context of geospatial. And this has been piloted here in San Leandro. This is what we've been using when we've been visualizing data from the connectivity we have here in San Leandro. We're getting ready to launch this product into the marketplace. We expect this to be just a real barn burner, but it was tested and driven right here in San Leandro. Take a look at that. This is just an individual building, and our ability to get down to the thermostat level and get that sensor level data out of the thermostat in a single building and pull that up so we can start to look at how efficiently buildings are at scale doing their heating and cooling operations, building startups. Is everybody comfortable? That kind of thing. And if you abstract that up to a whole level and you start to think about that at a city scale, and then you start to bring the buildings together, you bring the traffic infrastructure together, the water infrastructure together, and we have that level of granularity and visibility for situational awareness. We can start to do sustainability and energy efficiency plays, and importantly, resiliency. When we have events that are going to occur, natural or man-made events, now we have the ability to understand the geospatial context of where an event occurs and what kind of impact it might have to other services. So with that, I'd like to finish with a short video, and then we'll move to a panel. So if I could get a little help to run this.